something about the routing. So IP route, it gives me something. Then you need to understand what it is. It says default 192.168.7.1. I know from my IPA, these three numbers are fixed because it says /24, then these three numbers are fixed. Only the last one number, then what number one is designated for this routing. So number one is called, we call this is a gateway. All the packets coming to the address 192.168.7 dot something. So to your laptop, to my laptop, some laptops here, then all of those coming through one gateway. So we set up the gateway. So default via, so you know via, through this gateway. This gateway has some of the device. It is called, that device is wireless LAN. So what protocol is used? Protocol DHCP. So dynamic host configuration protocol. Okay? So what that means is that from this gateway, when I reach your laptop, then your address is the address dynamically assigned through that protocol, DHCP. It is not static the IP address. Source, right now my source is 192.167.8. Matrix 600 means what is the priority of my laptop. There's a 600. 600 is a high priority or low priority. Usually when we say priority, then you are the priority number one, right? 600 means very, very low. I think you guys has also 600, right? Alexandra, what is your priority? Matrix? When do?
600.
Yeah, 600. So 600 is very, very common. If you are the network professionals, then some packets, if you want to expedite it, if you want to make it, if you want to boost the priority, you could do that manually, but by default, 600. That is what it means, okay? I'm not telling you all of those, but you can, IP route gives you some result, some of the output, right? Number one, you need to understand, you need to know the command. Command is IP space route. Number two, you need to understand what it means. Just as I explained, right? So you guys need to see, oh, my router is doing something like that. What is my gateway address? 192.168.7.1, right? So you can do, so from this is a default. Then what is my case? My case is this, device WLAN, and then protocol, kernel scope link, and source is this, matrix 600. Okay. Is there any more detailed information available? Of course, there is more detailed information available. Then you need to investigate IP packets. You have to unpack IPs. You need to look at each bit of that IP packets. Is it possible? Yes, it is possible. Can you make it in codings? Of course, right? Remember that one of the textbook, I didn't ask you. Yeah, not in this class. But I wrote one book that is available on Amazon. But there, you can do code in Python to catch out to deep investigations of the network packets. Okay, and there's a command. Old command for this view routing is route -n, like ifconfig. By the way, iwconfig, that is for wireless. Route, like ifconfig, the newest the command that cover ifconfig is IP. Similarly, route, that is old version of looking at the routing table, but now we have a very powerful command called IP. So IP route. Okay, if it's that we can see. Similarly, route -n, then you may be able to see similar ones. So which one's better? I'm not sure. This is some language like coding language, right? This is a real table. Columns and rows. Explained, this is gateway. And matrix 600, interface WLAN 0. This guy may said more, right? Protocol, and then kernel scope link. What else? Yeah, something like that. So this is a new commands. Again, if I says, what is a command that I want to see? Gateway. Then IP route or route -n. Okay, display all open network ports. Oh, this is good, right? Open network ports. There's a command called SS. There's a SS. There's a socket. I think socket script. Socket is a very, very important. What is a socket? What is a socket? In general. Huh? Yeah, like sockets, right? The power outlets. There is also sockets and like a port, right? So it is, in other words, it is called port. But in coding, we call that socket. So socket, there is a, when I was a student, then socket programmer is the most sophisticated level of programming. Socket programming. It look at the ports, it opens, it dismantles all the packets all the way down to bits. So we look at each bits. Okay. So SS is a command for that. SS -TU, then T means TCP, U means UDP. TCP and UDP. Evans, you learned that protocol, right? Yeah. TCP, UDP. Right, TCP, UDP, that what level of the protocols, TCP, UDP? If you look at the 7 layers of a network.
Transport layer?
Huh?
There's 3.
3 means?
I think the transport layer, I think, top of my head.
Yeah, there's a transport layer. If it's a network layer, then IP. And then one layer up, then transport layer. Number 3 means counting from the top or from the bottom? I think from bottom, right? Level 1, then there's a physical layer. Okay. That's one network. Okay, if you do SS -TU, then it gives you some of the information. And then UDP, we have to extend more. Okay, I think this is net IDs, UDP and TCP. State that established, received sending. Currently, nothing sending out, nothing receiving. And the local area port. So we have a port number. This is a port number. So TCP port is open. What is the port number? 5900. Okay. PO address, another port number for, this is a local, my address, 59. And then UDP, that is a little bit dynamic. Similar things that you can see. If we put here, before we go there, we have two options, TU, T for TCP, U for UDP, and then L, that's for long, and with number, then it gives me something like this, okay, long. So we have 4 UDPs and more TCPs, and then currently it is listening, therefore there's a port number 3306, 22, 631, 59. This is more this is a local address, right, as it says. 3306, I believe that is if you set up MySQL, then usually there's a port number default port number for each program. If your MySQL is running, then probably 33,306.05, that is open. And then 22, if you open SSH, secure shell, remember on your Raspberry Pi preference, Raspberry Pi configuration and interface, if you open SSH, currently that is open, SSH. And open means, yeah. If you switch this left, then I2C, that is closed. iWire, that is closed. Remote GPIO, that is closed. But serial ports, VNC, that is open, and SSH, that is open. So one of those here, right now, 22, that is SSH port. Port number for SSH programs. If you come to Long Island port, C port, then there is a some of the gateway you can go through, right? That's different from, for example, Miami C ports. Then there's different program is rating, right? Each program has its own port, and when that program is running, then that program open a designated ports. So 22 is for SSH. VNC, I think one of VNC uses 22. I think one of those is used by VNC. What else? Yeah. Okay. So we can see the ports. So this is important, right? Another one here, Telnet. It says Telnet here, right? Has anybody used the Telnet so far? Probably not. It's not available in your case. Why it is not available? If it is not available, why still somebody said Telnet? Telnet is prohibited, as I said here. When I was a student, long time ago, we used the Telnet a lot. We play with the Telnet. What Telnet can do, it can make it blackmails. You can send out mail as if you are someone using Telnet. You cannot trace back. You can set up your own IPs, you own everything using Telnet. You can say, hey, I'm writing this from White House. Possible, right? So that is prohibited. Okay. So about 30 years ago, Telnet was popular among students, so we played a lot using Telnet till maybe 20 years ago. And since then, Telnet is still available, Telnet program, but they have always warning signs. I think since 10 years ago, Telnet program is completely removed from anyone's the computer. So Telnet name only available. Instead, we have more powerful ones. Netcat, NC. Okay. What Telnet can do is support connectivities. Okay, so I'm going to push this away and let's look at. So Telnet is not possible. It says Telnet not found. NC, if NC is not available at your side, then you need to do what you need to do. You need to install, right? Sudo apt install. Maybe NC is not available. Some other program number. Let's try with this first. Right, NC is not. Let's see if I have. This is not on your slide. This is something more than that. Oh, no. Okay. Maybe then Netcat. NC is not installed. Maybe Netcat. Netcat is not. I forgot. In this case, you need to look up the menu, web browser, and then you can say how to install NC on Raspberry Pi OS. Then you can find out. Okay. No, this is not. How to find the question about NC Netcat in Raspberry Pi. How to install? How to install? Maybe. Why? Video. I want to command the line. I think it is maybe netutil. Maybe. So let's try to netutil. Netutil. No, not netutil. I installed it, but I do not remember that. Okay. Give me a sec. Yeah, I got that here. So what you need to do is netcat OpenBSD. Okay, netcat dash OpenBSD. That is or traditional. Netcat traditional. Netcat BSD. What is a BSD usually? BSD. You probably heard of a BSD here and there. BSD stands for Berkeley Software Distributions. So almost all the Unix operating systems first developed at UC Berkeley, and also a Bell Lab here in New Jersey. So that is installed. Now you can do NC minus ZB google.com and 80 connected to google.com port 80. That is succeeded, right? That's what it is. And then you can see NC for the manuals, then arbitrary TCP UDP connection and listeners gives me some of those. This is a BSD versions, but you can do also here traditional netcat dash traditional. Then that's already yeah, something already is already NetWest versions. This is from that I installed. So if I want to remove, I can do remove. But anyway, so one version is enough. Okay, so next slide that I looked at. This is for extra, so my extra versions. Okay, lookup. Now NS lookup. Again, NS lookup, that is typical command, has been improved by Dick. Okay, so if you want to install the command Dick, there's no way that you can install Dick itself, I believe. For example, if you do sudo apt install Dick, then there is no Dick. Okay, so what you need to do is you need to do sudo apt install DNS utils. What is DNS? DNS stands for Evans? Domain name service. Okay. So for example, the address can be address physically by number 192.168, whatever, 192.168.68, whatever. That's a number. But when you try to visit, for example, www.google.com, then you don't really remember number for that, right? You simply remember www.google.com or www.mercy.edu. You want to keep the name rather than numbers, right? Name is better. But when you request something by name, then name needs to be converted, translated to anyway certain number, right? So all those things can be handled by DNS. So lots of utilities required. In that way, we need to install the command DNS utils. Okay. typically we say NS lookup google.com, then we may be able to see domain name is google.com, address, IP address is 142.250.64.110, and name for, and then this is MAC address. So this is IP address, and this is a MAC address. I believe this is MAC address. A little different. This is not MAC. Okay, but anyway, this is the ones. But if you use the new versions, then dig google.com, then this is a little different, right? Remember that previously we had this simple ones. Now we have something probably more, right? So I don't really go through this, but here Monday, April 7, that is timestamps and subsections. Okay, now it's time for us to look at the manual of dig. Manual dig. That is for DNS lookup utilities. Dig, and we can put some server like google.com. And then here's simple usages. Typical invocation of Google looks like that. Server name type, lots of utilities available. It's a long list, right? Okay. This dig itself, you need to learn a lot more about domain name services. So that is DNS lookup. The next one is trace routes to host. So that is a command called trace route. Google.com, then you can see, that is each points that we see. When I go to Google.com, we know how my request to go through. If we see some of those here, it has 30 hops. So trace, this is the maximum number. It allows us 65 packets. Initially, it goes through the gateway, right? So my laptop is 192.168.7.8. So go to the gateway. So my message pass first through the gateway to go out. And after that, it goes to 2430. This is somehow Spectrum.com, some of the routing companies, right? And then infspectrum.com, here NYC, NM, whatever, and netopscharter.com, similar to that, and then netopscharter.com here. They're all different IPs so far. And number 7 here, this is similar to that. Number 8. Now here and there, and finally it goes through 142 somewhere here, right? So what it means, and it's a lookup, and 142.256.3, 142.64, 142.164, 110. This domain name server of that installed for google.com is 142.250.65.238. This is specific IP address, right? Before, to get to this specific 238, one port before coming to this, that is 110. Okay? So we traced how my packet can reach the destination. We can see that clearly also look up mercy.edu, then address is 23.185.0.1. That is a mercy.edu. We can do also trace mercy.edu. Oh, because there is a this means packet is not successfully reaching. I think 30 hop maximum, right? Yeah, maximum. 30 is maximum. As it says, 30 hops maximum. It doesn't reach. What's that idea? www.mercy.edu. Again. Okay, we don't need to do. Let's look at something else. And let's look up cs.columbia.edu. Then 128.59.11.206, and I want to do it reaches the 100 and somewhere in Colombia, right? But it lost somewhere. See here, 100, 128.59.11. 128.59 some, right? So in this way, we need to see how it reaches. Okay. Oh, from here, how can we download some web content? There are two ways that you can do: wget or CURL. So you can reach something from there. For example, wget http okay, so wget sitesecure.org. This is our the cybersecurity program, right? It's still running. I didn't know that it is still running. This is Mercy College. It's a long time ago. I developed this, but I don't really do. So it if you go to here, this is a first page, right? Index.html file that has been downloaded, right? So if you see here, CD download, is this? Yeah, CD download. Oh, it's not done yet. So probably if I want to save it, where is it saved? Saved to that. Oh, here. So we already saved it there. So we looked at that. So for example, head index.html, then we see let's take a look at more. Cat index.html. For example, any comments, please contact Jayun Mercy.edu. That's me, right? That's what you can see here at the end of this. For any comments, please contact John. So that is your web page can be accessed by wget. Similarly, another command that you can get is CURL. And then HTTP scitesql.org, same thing, right? Firewall rule. This firewall rules can be also found. So IP is called IP tables. So man IP tables, then you can see the manual. If it is not installed, then you have to install it. It is IP tables is administration tools, packet filtering, and NET. NET is another protocol. Name, I think that is a T for translations. I think network address translations, I guess. So that is possible. IP tables, network address can be, this table shows us network address. So let's see how it goes. That, and if I do IP tables -L, -N, and -V, then it needs system administrator's privileges. Therefore, we need to do sudo. Why IP? So far, we didn't do sudo privileges. This is the first time that we encounter that barrier. Permission is needed because IP tables contains the sensitive information. One of the most sensitive information. If you see this information, then you may be able to see that. Right now, it doesn't show anything, right? Because we do not have any here. But it shows chain input, forward, and output. What it does here is, if some packet comes in, then this table tells us where to go. Okay, I think I have, this is for the, I want to see it. Okay. All right. This shows us more, right? So IP tables, managing packet filtering. This slide is not available at hands out. You don't need to know in detail, but I wanted to see, if you're interested in, then you can go deeper and deeper. But at your level, this, I'm going to explain simply what it is. I don't remember all of this also. So IP table, what it does is it's a legal legacy. It's not really the new commands. Legacy firewall tool in Linux for managing packet filterings. Options -L means list current rules. -N don't resolve IPs or host name. What it means, if you have a -N, then if some address comes in, some package comes in with some destination IP address, then sometimes no service is given to that packets, right? Is maybe denied for some reason. All those things can be done by filtering rules. So we can see the rule. Input rules, forward rules, and output rules. Input rules to handle incoming tables to your laptop, in our case, Raspberry Pi, right? Forward rules, it handles the traffic passing through your device. Output rules handles outgoing traffic from your device. So the packet rules could be like this. If you want to add the rules saying that all input packets automatically drop, for security reasons, you do not allow, first of all, any packets by default, I want to drop it. Okay, there is another rule. So IP policy -P means I want to set up the policy for IP tables. My policy, my bottom principle, my bottom line policy is to drop all the packets. But I want to add more specific rules, so -A, for that input. If there is a protocol in TCP, so -P is kind of protocol. TCP, if it is the TCP protocol, that protocol comes into port number 22, I want to accept it. Okay? That kind of rules can be designed by network administrators. So that is a little detailed, right? Therefore, I didn't include. But those who are interested in the network, I want to open your eyes to look at some ideas, understand some concept. So each rules, firewall has a number of rules set up. How many? Sometimes hundreds and thousands of rules set up. At each time they set up, like sudo IP tables, -A for attach. I want to attach the input, that's a keyword. I want to attach the input rule followed by something, -P. I want to make a rule, something about the protocols. Another one is I want to make a rule, something about states. States about the packet states. If a packet state is to establish or relate, still I want to accept. If some other network wants to establish the connect to our infrastructure, according to that rule, first the establishment, I want to accept it. Okay, that type of rules, hundreds of such types of rules can be attached. Then at the end, what happens? System administrator, network administrator, cybersecurity administrator, and they'll end up having some difficulties. They are confused. They don't have clear principles, clear policy for managing the network packets, because so many rules applied. One rule may be conflict with the other rules, because earlier rules, our policy is A. Later rules, our policy is not A. A rule and not A rules two rules are conflict, right? That may be possible. But anyway, that's what I want to say to you. Okay, that's IP tables. Now ARP tables, address resolution tables, ARP minus A. So let's do here, ARP minus A. Oh, this is something. This ARP, this is IP address, right? 192.168.7.1. What is this? This is gateway, right? And then 7.18, and then 7.128. Each one has, what is this? This is a MAC address. So ARP is handles MAC address. What is a MAC address? Yeah, each device has a unique identifier. It is called the MAC address. So I have another. Okay, here I want to jump to explain about this. So let's look at MAC address. It's called the Media Access Control Address. MAC address is nothing but a unique identifier assigned to your NIC, Network Interface Controller. This NIC if you were taking computer science course in about 20 years ago, then you probably understand what is a NIC. And then there's a NIC card, network card. So on your laptop, desktop. At that time, desktop was popular. Most of the students use this desktop 15 years ago. Then that laptop has some of the slots. There is a network card. We call the NIC card, network interface controllers there. Okay, we call that. There's Ethernet card, not Wi-Fi. Right now we are talking about Wi-Fi, either Wi-Fi wireless or Ethernet, which is the physical connections. If it reaches that device, the device has unique identifier like this in hexacode. So six bytes long, right? So 1, 2, 3, 1, 2, 3, 6 bytes long in hexacode. So there's a unique identifiers there. Why MAC address is important? First of all, there is a device identifications. MAC address help a network distinguish between device. Like here, in this ARP, under one network, domain network, under one subnet, under your wireless the router, then devices connected to that router, including your phone device. Therefore, there is a identifiers. When message comes in, then router decides which device it should relay the packets to. Okay. In that case, this MAC address is used. So your router uses a MAC address to assign IP address via DHCP. So looking at that MAC address, now your router assigned IP number, although that is temporary, although that is dynamic, not static, but based upon that MAC address. Therefore, local area network is possible. So layer 2, data link layer, from the physical layer 1 and data link layer, that is 2. So if you say MAC, then that is always in this level 2, data link layer. And that network control is possible. So network can restrict access using MAC address. If you want to restrict, or you can allow. For example, only devices with some allowed address can connect to the school or office Wi-Fi. Probably when you were in middle school or high school, if you bring your laptop, then you need to go to technicians, school technicians, and school technicians look at your laptop. Laptop is not given from your school, but you bring it from your home, but you still wants to access the internet, school internet, then they ask you to bring your laptop. Why they ask you to bring your laptop? They want to get MAC address from your laptop and then store that MAC address on their router. From that time, on your router, then that has this kind of, your MAC address can have some IPs. From there, you can access your internet. Therefore, MAC address is needed. So MAC address is important that help your the internet connections. For the same reason, therefore it is dangerous, right? Gregory, what if we dismiss earlier? But I'm glad you are still joining us. Okay, so tracking and privacy concerns. MAC addresses are persistent and unique, therefore if a hacker may tweak your MAC address, then your MAC address, your iPhone, not only iPhone, your smartphone is no longer connectable. Okay, if your MAC address is tweaked, randomized access. MAC address spoofing impersonation is possible, like this, but we are not going to practice this. Warning risk includes bypassing MAC-based access control, intercepting traffic, and then impersonating a trusted device on a network. So attacker can spoof your network access. Weak network securities. If your network relies solely on MAC filtering, it can be bypassed easily with spoofing. It is not a substitute for encrypting like WPA 2, 3. Okay. So how to view your MAC address? This is you can see the MAC address from ifconfig we looked at, right? Earlier, and IP link also gives you. IP link gives you a MAC address. Where is the MAC address? This is 2C:CF:67:51:CA:64. This is being used right now, right? Okay, now monitoring network traffic. IFTOP. We can IF top. So it is still need sudo, so we can do sudo if top. Then if there is some networks, I want to see some of the, let's see, Mercy University. See if there is any updates. It's not really being updated. More dynamic ones. CNN.it, CNN.com. It doesn't really appear here. Transmit, receive. We don't really catch here. So Control C, and then let's look at end load. So we can see more clearly incoming packets and outgoing packets. Right now, nothing coming in here. Oh, this is through Ethernet 1. That may be the reason. We need to look at the wireless, right? Through the Ethernet, of course, there is no. Okay. Also, we can see the manual. Display current network usages, MAC scaling interface. Okay. Mac end load -A, then maybe for 30-second -I -M, max scaling interval. So you period max -M multiple device -T interval. Device. How can we check? Because there is no specific traffic so that we can see. Actually, my Raspberry Pi don't do much, therefore we don't really see here. If we could see it, it would be very helpful. But there's a network managed status. This is a GUI based. This is a brand new command. NMC. NMC means network management. NM means network management. CLI stands for Command Line Interface. Okay, Network Management Command Line Interface. So we can try here Network Management Command Line Interface, and then we need to look at the, let's see, manual first. Network Management Command Line Interface, manual. This command line tool for control network managers, options, general network radio connections, device agents. So we can say this is for device right now. If we want to see device, and then there is a radio. I think there's a general. So we may try general, radio, and device. A for ask, C for color. This is for, okay. So NMCLI DEV, let's see that status. Then we see here Wi-Fi is currently connected. Loopback is always. And Ethernet, that is unavailable. Therefore, when you do nload, it looks at the, it try to look at F0. It is unavailable, of course. Therefore, there's nothing, right? This wireless LAN is connected to. This shows me the SSID also. My Raspberry Pi is connecting MT CIS Lab Wi-Fi, like yours as well, right? That is a device status. NMCLI, let's see, radio. So what it is. So Wi-Fi HW enabled, Wi-Fi enabled, WAN enabled, wide area wireless area network HW, that's missing. If we say here general, yeah. So that is a command for that. Static IP address, if you want to assign the static IP address temporarily, you can use this, but we don't do that here. And flush DNS cache, only if we are using system resolved, but we don't really do here. Oops. Okay, wireless networking. Configuration is, your device configuration is IF config, right? But for wireless, you can do IW config. Then only something about wireless. And then if you want to set up SSID manually, then you can set sudo IW config WLAN 0. Right now, WLAN 0 SSID is this, right? This is the router that we look for. And the frequency is 2.4 gigahertz. You can set the differently if you want. I don't want to mess up my Raspberry Pi, but take a look at this. This is possible, right? If we want to change it, SSID, you can do that. If you want to change the frequency, rather than my real frequency, if I want to change it, you can do that. My frequency is 2.412 gigahertz. If I want to change it, whatever the other, then possible. key also. You can, key is not shown here, right? But WEP keys can be set. But our router here, there's a WPA2 keys. It's not WEP keys. But this language tells you the way that you can manipulate wireless networkings. Okay, I think this is NMCLI connection show. So NMCLI connection show. So this is a router, our router, and this, and the network device is WLAN 0. Signal is Wi-Fi signals. Then UUID is this. This is a unique ID as well. This connection unique ID. We don't really use UUID, but some sophisticated connections, it asks you to enter UUID. You may see that inquiry along the way that you work on this area, this technologies. Then if it is required for you to enter UUID, then you can come back here, NMCLI connection shows, then you can see that UUID. It happens sometimes. Okay. I think. All right. Now this is a very interesting. This is the final technique that we are going to work today. How can we see the network speed? How can you measure the network speed between two devices? Then we need to install iPuff Performance 3, iPuff. Once you install this, then you can start iPuff -S, this is for server, -C, that is a client. Then you need to, your client needs to connect to your server with the server IP address. Then you can see at both sides, let's say WPA, or this is one Raspberry Pi and another Raspberry Pi, then server needs to first to run, and then client can access, then you will see the performance. That can be done not only between Raspberry Pi, but also from your Mac Pro. So what I want to show to you, okay, I have here, this is my Raspberry Pi. So I can say iPuff 3 -S. Okay, I want to run my Raspberry Pi as a server. Then it waits for that. And then from my laptop command line, I want to, of course you have to install iPuff 3. By the way, if you want to see how to install, then you need to do, you can install it using Brew. Okay, you can brew it. Brew, check the version if Brew is available. And then you can do, you can install it from, you can download it from GitHub, usercontent.com, homebrew, install, head, install.sh. You download this in command line. How can you download? Using CURL. Remember the CURL or wget, those two commands that you can get the files, right? So you need to get the files from this website. Then you will get IPOP3 command, and then you need to brew it. Brew install IPOP3 and check the versions. Okay, so assume that you have your IPOP3 is available, and you want to as a client -c, because you have your own server is currently running, and then you need to put 192.168.7.8. This is the address for your Raspberry Pi, right? See if they are communicating. So I'm talking about from my laptop to my Raspberry Pi. I'm curious. Here at school, it was good. My home. So my IPOP3 server is running. Now client to run. I'm going to hit enter. It's connecting. Remember here is receives. So sender speed is this is transfer speed is 26.22 megabytes. So 22 megabit per second speed. Receiver, the client, my case. So server is pretty good, right? This is the server side. So what I want to do, remember that we were not able to do some of the, let's check. Because we know now we can communicate, we use the network. So something that we didn't use, I'm going to use that. Check the traffics. There's two commands available, iftop or nload. So I want to launch nload here. So nload. So nload is monitoring the traffic to see if this guy can catch up the traffics. Right now, this terminal is running IPOP3 server terminals. This is nload monitoring tool. I want to communicate to, this is a laptop terminal. So I want to hit enter and see how this goes, okay? So hit enter. This is not really, because this is, as I said, this is Ethernet, not the wireless, not WLAN. Yeah, that is the reason. Monitoring network traffics. This guy is doing the network traffics through the Ethernet only. Let's see, sudo iftop. And I want to redo this. Again, this is only Ethernets. trying to look up Linux command line to monitor WLAN traffic. Network traffic that we know, right? node, NMCLI. We're talking about wireless. How to network Linux systems. Doesn't show it. 90 monitor. Let's see. 90. node that we looked at, right? node. So I want to see. Keep traffic. What is this? node. B bandwidth monitor. Packet. B monitor bandwidth monitor. Slow monitors network load by showing a device status. I think there is some tools available. Speedometer minus ENPOS 32. That's net load. Wireless. Current traffic load number of IF top that we looked at. That works for Ethernet only, right? Traffic. How can you do? Is there any way that we can do? And options used to prevent creating additional network traffic. TCP tracks. I think there is some, but I will find out and show to you if it is available by next week. But I'm now not sure. This is all third-party vendor products, not the typical Linux command. So, but I think that there may be something available. Then we'll get more interesting result like here. Okay, we see some of the performance. This time performance is not the same as previous time, right? You can see this is 22.3, 25.6. In the previous ones, 26.3, 23.0. So at each time, it gives us a different performance, of course, right? Different speed. All right. Any questions so far? I think this is almost done. Okay. This is what we did. Yeah.